Good morning, everyone, and welcome back. Today we are switching gears, and this whole last unit of the class is focusing on consumer mathematics or financial mathematics. So we're going to be looking at math that you are very likely to encounter, throughout the course of your life. So we'll start with simple and compound interest. Beginning with simple interest. Simple interest is calculated as one lump sum based on the total. So that means if you've invested, say, $1,000 in an account, and you're going to let it sit there for a year and it earns, let's say, 10% simple interest, then your interest earned on that account is going to be 10% of that one-time deposit of $1,000. So that would be $100. The second type of interest we're going to look at is compound interest, and in that case you can earn interest on your interest. So the difference is, if you have simple interest, if that account with $1,000 were to remain there for, say, another 10 years, every year you would only earn interest on the original $1,000 deposit. Whereas in compound interest, you will earn interest on the original deposit as well as any other interest that you have earned previously. So we'll look at compound interest second, but let's start with simple interest. Simple interest is sort of the foundation for all of these different things that we can do. Interest is computed by taking the principal, which is your initial investment, times the interest rate times time. The interest rate will typically be given to you as a percentage within the problem, and you want to convert that to a decimal by dividing by 100. And time, the key thing to remember here is that time has to be in years. And so if you have a time of months, you want to think of those months as a fraction of a year. The future value of an account is determined by taking the initial deposit plus the interest that you've earned. So that would be P plus I. Now, we have a formula for I, though. I is given by PRT. And so now we have an equation where both factors could be, both terms in our expression here have a common factor of P. So if we factor out P, then we are left with 1 plus RT. And this is the formula that we typically use for future value. So if we're referring to future value, then we're talking about this formula right here, A equals P times 1 plus RT. This is only the future value formula for simple interest. Compound interest will have a different future value formula. The other thing to keep in mind, sometimes we will solve for the present value, and that's also what we call the principal. So how much are you investing today? And so that's your present value. So future value or present value, we'll use the same equation, just solve for a different variable. So let's take a look at how we can actually use this to do something. We want to determine the interest earned on a loan of $100 at 12% over 9 months. So first off, and we can assume this is simple interest because we're in the simple interest section right here, but in the future I'll make sure to say 12% simple, with simple interest. So that way it's very clear if we have simple or compound or whatever. We're trying to find the interest earned, so that means we're going to be using the interest formula, so I equals P times R times T. And so what I like to do is just sort of list on the side what I know, what I'm trying to find, and anything else that might be helpful. So since I'm going to use the interest formula, I've listed all the variables within the interest formula. So let's go through the sentence and figure out what we know. We have a loan of $100, so that is our initial investment, or in this case our initial borrowing was $100. The interest rate is 12%, and so 12% as a decimal would be 0.12, and we get that by dividing 12 by 100. So our interest rate is 0.12, and the time is 9 months. Now, if I just said T equals 9, that would indicate 9 years, and that's not what we have here. We have 9 months. So I have 9 months out of 12 months in a year. So I have 3/4 of a year. You can leave it as 9 over 12, or you can rewrite it as 3/4. The thing that we're looking for is the total amount of interest. So I'll just you can leave it blank or put a question mark, something to indicate that we don't know what that is. So now we can go ahead and set up our equation. So interest, which is unknown, is going to equal our principal, so $100, times the interest rate, 0.12, times time, which is 9/12. And then you want to go ahead and use your calculator to multiply this through. And so we end up with interest being $9. So $100 invested at 12% for 9 months gave us $9. Does this seem reasonable? It should seem kind of reasonable. We had 12% over the whole year. So if we break that up into months, so 12% divided by 12, that means we're earning 1% every month. So if I've invested for 9 months, then I should have 9% back in interest, and 9% of 100 would be $9. So this should seem reasonable. Let's take a look at another example. We want to know, what is the total amount due on a loan of $800 at 9% simple interest at the end of 4 months? So in this case, we are not being asked to solve for the amount of interest. We're being asked to find the total amount due. And so this tells us that we're interested in future value. We want to know, how much are we going to owe on this loan in the future? So since we want future value, our formula is A equals P times the quantity 1 plus RT. So remember, we're using future value, which is right here, 1 plus RT with the principal factored out. So again, let's sort of list what we know, and I'm listing all the variables from the formula, A, P, R, and T. What is the total amount due? So we don't know the future value. On a loan of $800, so we know the principal was $800. At 9% simple interest, so we have interest is 0.09. Don't forget to convert it to a decimal. And then at the end of 4 months. So again, 4 months, so this means we have 4/12 of a year, or 1/3 of a year. So now we can go ahead and set this up. So A is going to equal 800 times 1 plus 0.09, and the 0.09 is being multiplied by the 4/12. So be careful here with your order of operations. 0.09 is multiplied by 4/12, and then it gets added to the 1. And so we end up with 800 times 1.03, and that, 800, not 80, times 1.03, and we end up with $824. So if you take out a loan at 9% simple interest, and you borrow $800, then at the end of 4 months you are going to owe $824. So you're paying an extra $24 because you borrowed this money, so you have to pay interest on that money. Let's look at another example with simple interest. This time we want to know, how much should we invest? So this is asking us for the principal. So how much should we invest at 15% simple interest to have $5,000 in 2 years? So in this case, we're solving for the present value, but we're still using the same formula. A equals P times 1 plus R times T. So let's go ahead and list the variables A, P, R, and T. And let's see, 15% simple interest, so the interest rate would be 0.15. We would like to have $5,000 in the future. So A is going to be $5,000, and the time is 2 years. This time we do have years, so we don't have to do a fraction of 12. And so even if we weren't clear from the problem what we were supposed to solve for, if we can identify what each of the pieces represent, then the leftover is the principal. And so then that tells us we're solving for the principal. So let's go ahead and set up our equation. We have $5,000 equals our unknown principal times 1 plus 0.15 times 2. And again, make sure you do the order of operations. 0.15 gets multiplied by 2 first, and then we can add it to 1. So we have 5,000 equals 1.30 P. And so if we divide by 1.30, we will be able to solve for the principal. And we end up with 38 46.16 being our principal. In general, if you're solving for the principal, you want to round up to the next penny. So the answer on the calculator was like 152 after the decimal. Always round up to the next penny, because if you invest a little less, then it's possible that you could end up not making your $5,000 goal. But if you invest an extra penny at the beginning, then you're definitely going to hit your $5,000, and you might be over like a penny later on. So it's better to be over a little bit than to be under that $5,000. So when you're solving for principal, you always want to round up to the next penny, okay, if you have a partial penny. All right, so that's all for simple interest. We've seen examples where we found future value, the principal, and just sort of evaluated for interest. Keep in mind that you could use this equation to solve for the interest rate or to solve for the time. So there's lots of different things that we can do with this equation, but anything involving simple interest is going to use either this future value equation that we have right here, or the fact that interest is equal to PRT. So anything relating to simple interest will be coming from these two equations. All right. So when we come back, we'll take a look at compound interest.